Hi everyone, this is the marketing research lecture for week 7. It is in relation to preparing the data before we start the proper statistical analysis on our quantitative data set. In this lecture we are assuming that you have collected your data already, but in terms of I'll be using various existing data sets rather than your actual data in demonstrating how to prepare data and how to check for errors and how to run your initial checks that your data entry has been correct. This relates to chapter 13 of your textbook. So, I'll initially be looking at the process of establishing the data quality overall. So this process includes data validation, data editing and coding, data entry and error detection, often called error checking. And I'll also look at the preliminary data analysis, which relates to tabulation, measures of central tendency, and measures of dispersion. So, when looking at quantitative data analysis, it's all about statistics, the analysis of the output, and the interpretation. Just remember, it's the interpretation that is the most important stage in all of this process. So right at the end, I'll demonstrate what the interpretation looks like. So this week's lecture relates to Learning Objective 4. We need to establish the methodological quality, reliability, and validity of the data collected. In particular, we are looking at the validity and accuracy of the data, because it needs to go from the process of collecting the data to be inputted into a data set on which all analysis will then be based. So we need to get that data set as accurate and error-free as possible. So the first step of establishing the first step is establishing the data quality. We need to ensure the validity and reliability of our data by answering the following questions. Was it collected appropriately? So we should have already made decisions around the data collection process. However, there's a difference between how the design of a data collection process versus what actually happened. So we need to ensure that the design was actually implemented appropriately without any basically fraud, mistakes, those sorts of things. Did you pay someone to do more intercepts, but they got tired and bored, so they sat in a corner and filled in 100 surveys all by themselves? That's the kind of thing that needs to be checked for in terms of collection checking. Is the data itself free from errors? So unless you are doing things like online surveys, usually there is an extra step between the data being collected versus the data that then appears in the data set. So there needs to be some checking between what is in the collected data versus what is in the data set that is analyzed. Are the measures that we've used appropriate and accurate? So this is a reliability and validity checking of our variables in relation to the constructs that we were trying to measure. And does the sample represent the population? So we have our sampling plan, but again, in its implementation, things can change, and its representativeness of the population can also change. So the data preparation process is this error detection at the validation, editing and encoding, data entry, data tabulation stages. Before we get to data analysis, where we have different types of analysis techniques of descriptive, univariate, bivariate, and multivariate analysis, which ultimately we then have to interpret in order to form conclusions that are reported to the client. So the data preparation process. We're just going to talk about data validation. How do we ensure that the data that was collected is accurate and was free of data collection errors such as I described previously? So some of the things we need to check for are fraud. Was the person actually interviewed? So often if you're doing telephone interviews or possibly Mall Intercept interviews, you can engage in a process of calling someone back and asking them, did you talk to us on this date at this time? Just to check to see whether the person doing the data collection is not falsifying interview data or survey data. Screening. So validation callback to verify screening factors of criteria. So if you had age or income or gender as a screening criteria for someone to do a survey or quantitative instrument, was that screening applied appropriately, or did someone do it without having the correct criteria? Procedure validations also it can involve callbacks to make sure that the interview took place at the proper setting, following the proper procedures. Did the interviewer tell you this? Did you get asked to do X? These kinds of questions. Completeness. Basically, we can recontact the same respondent and ask questions from different parts of the interview to make sure that all questions were asked. So maybe the data collection person did do the interview, but in order to do more interviews quicker, they skipped sections and filled them out themselves. And we can just do courtesy, basically just to make sure that the interviewer was courteous, pleasant, and professional in their conduct. Just be aware that these kinds of data validation checks rely on someone being willing to talk to you again, and also can be quite an expensive process of checking the data. So the second stage of the data preparation process is the data editing and coding. I'm going to talk about the Brumbies survey that I did as part of my PhD here. Basically, this is where turning your survey instrument and telling whoever is inputting the data what should be inputted when a person responds in certain ways. So we can do a check here. Basically, we can check completed data or interviews for mistakes made by the interviewer or the respondents. So we need to check whether they're asking the proper questions. We can record proper recording of answers, screening of respondents, and proper recording of open-ended questions. So what do we do in terms of this assigning or grouping values to certain types of responses? So the best thing to do here is incorporate the coding into the questionnaire design. Sometimes this is not possible, and in some cases incorporating the coding into the design can just confuse the respondent, so we sometimes leave it out. If it's not incorporated into the questionnaire design, we need to assign a coded value to each response. We try and use numeric codes as much as possible. We need to figure out what codes we're going to assign to missing data, and we need to look at how to code open-ended questions. I have created a different video to deal with this last point of looking at 3 different approaches to dealing with open-ended questions in a survey instrument. So here is my survey that I used as part of my PhD. I did a study on Brumbies fans. For those who don't know, the Brumbies is the Canberra rugby union team. So this data was collected at the game. It was a piece of paper where people I did it on thick paper, provided pens, so people in their seats or as they're walking to their seats were basically intercepted and asked to complete this survey. So by its design and in data collection design, it had to be a relatively short and easy to complete survey. So here is what it looked like. As you can see, I incorporated coding into these questions on the left-hand side here. However, the questions down here and on the back page would have just confused people if I tried to incorporate the coding there. So in terms of the constructs that I was measuring and the variables I used. So the first questions 1 to 7, the variables I was using was the celebrity attitude scale, which I used in relation to brands in this case, and the construct was brand worship. I then had an open-ended question for favourite player at question 8. Question 9 to 15, I again used a celebrity attitude scale, but in this case it was related to the player, and the construct was player worship. Questions 16 to 18 is brand commitment. Questions 19, I had a slight numbering problem. 27 and 20 were future membership intention. Questions 21 to 23 were a construct for social identity salience. And finally, the important to needed questions, those what we call semantic differential scales, were measuring a construct called involvement. So the question now is, how should each of these questions be coded? And also I need to identify questions that are currently reverse coded, as in they're asked in a negative way. So these need to be transformed so that they are consistent with the questions around them in order for analysis to be performed. So what does this look like? Well, because I incorporated these already in my questions 1 to 23 are already coded as part of the design, I don't need to do anything. However, for each survey I assigned a respondent ID number, so in this case R0001. This allows me to do an error check where after everything has been inputted into my data set, I can randomly choose a respondent ID and double check to see whether these codes have been entered in accurately. So other coding that needed to happen, so my involvement scale down here, the important to needed questions, I coded at -3 to 3. So that means that the 0 becomes a possibility and it means neither or, and in terms of analysis it has specific meanings. So in terms of reverse coding, I have, but I'll get back to reverse coding. In my demographic items, you'll just see that I've coded everything 1, 2, 3, 4, 5, 1, 2, 3, 4, 1 to 8, 1 to 9, 1 to 6, and gender, I've just done males as 1, females as 2, and then I had a few open-ended questions. How many Brumbies signatures have you collected? How long have you supported the Brumbies to the closest year? So these I decided basically to input as is, and then decided to recode later as part of the analysis. So reverse coding. So to give you some idea of different types of reverse coding in terms of what this means. So if you look at question 22 versus question 23, I feel strong ties to other Brumbies fans. 1 strongly disagree versus 5 strongly agree. Whereas 23, which I've highlighted as needing reverse coding, I find it difficult to form a bond with other Brumbies fans, is essentially the opposite. It's a negatively phrased question, and it's within the design in order to make sure that people are paying attention when answering the question. So this is another way of looking at respondent error in terms of input. But in terms of including it in the analysis, once I have this information included in the data set, what I need to do is recode this item so that 5 becomes 1 and 1 becomes 5. Similarly, when you look at the involvement scale, We've got important, unimportant versus boring versus interesting. So here we have a negative word in boring and we have the positive word of important, both being inputted as -3, even though they in terms of the linguistic meaning, they are opposites. So here is another case where we need to recode the data set. So all of these items, the negative word is given a -3 and the positive word is given the 3. So what this ends up looking like is, I'm just finding my data set. So here is the data set for the Brumby survey, and it is this item here that is reverse coded. So there's another video that shows you how to input this data, but this is the just for demonstration purposes on how to recode an item. So to recode, we go to transform, recode into a different variable. I tend to use different variable to make sure that if there is a mistake in the recoding process, I can go back to the original variable and start again, which recoding into the same variable doesn't allow you to do. So I choose recode into different variables. So I select the item that I need to change, which is I find it difficult to. I then hit the arrow, so it is now appearing in this central box. I need to give this a name, this new output variable a name, so I call it SIS24 recoded, which is a recode of question 24, and I hit change. So now I've told SBS the original variable versus the target variable. I then go to old and new values and hit select. So this is a somewhat slow process, but bear with me. So because we have a scale from 1 to 5, we need to make 5 1 and 1 5. So I will start with the number 1 of the old value on the left, and on the right hand side the new value becomes 5, and I select add. In the old value 2 becomes 4, and I say add. Technically 3 becomes 3, not changing things, so that one you can skip, but I'm putting it in there just to show you the process. 4 becomes 2 and add, and 5 becomes 1, and we hit add, and I say continue. I don't want to do anything else, so I say OK. So in our data set, we now see that there is a new variable here called SIS24 recoded, which is my newly recoded into the correct scale for this social identity salience item. So I can move this one up to here, and I usually remove, oops-a-daisy, usually move the old variable down to the bottom so it's out of the way, and I know that this is the one, my new target variable. So that is the recode process. So we can do the same recoding process to this involvement scale, but instead of 1 becoming 5, -3 becomes 3. Similarly, we can do the same process of creating new categories by, in these demographic questions on the second page, C, D, and F, if I create categories, I can recode people's answers from these items, which are open-ended, into a specific category. But I discussed that further in the other video. So now I'm going to move on to data entry and error detection or checking. I'm going to use the Delhi Depot data set from here on when I look at the next two stages of the process. So The easiest way to look at error checking in your error checking process is to run and check the frequencies of all of your items. For the purpose of this video, I'm just going to focus on the Deli Depot item X1, friendly employees. So this is the basic output for a frequency analysis. So I'll come back and explain how to analyze this in a second. I'll show you how to do it first. So here are the instructions. So when running these frequencies, you do actually have two options in SPSS. You can do frequencies or you can do descriptives. So my Deli Depot data. So what do I mean by this? So we go to Analyze Descriptive Statistics. So you have two options. You can use frequencies or you can use descriptives. I like to use frequencies because I can get all of the same information, and I can also get a chart of that shows distributions as well, which, being a visual learner, I find it easier to look at. So I'm selecting frequencies, my X1 variable on the left. I then select the arrow so it's now on the right. I click statistics. So this is where in frequencies you can get all of your descriptive statistics as well. So in central tendency, I can get my 3 different central tendency measures: mean, median, and mode. In dispersion, I can just select all of them. I'll talk about them all later. And characterize posterior I assume that's dispersion, but who knows. I select skewness and kurtosis. And I set continue. Then I select charts. And I like the histogram and show normal curve on the histogram. And hit continue and select OK. So SPSS creates an output window. Here are my descriptive statistics. Here are my frequency output, and here is the histogram chart that I have asked it to produce as well. So how do we analyze these for error checking? So here again we have a frequency output if I didn't ask it for statistics. So error checking. The first thing to look for is whether there's missing data. Missing data means that the respondent either didn't respond to this question or the data inputter missed inputting an answer for this question. If this gives you an idea that you need to go back to the original source of the data to see whether there was an actual answer given. But often respondents do miss answering questions unless they are forced to put in an answer. So there are various decisions that need to be made. If there is data missing, what are you going to do? There are two main approaches to missing data. The first is to eliminate the respondent from the data set entirely, so you reduce your sample size by taking this approach. Or a common way of dealing with missing data is to input the mean for the entire series into that cell. The second approach means that you can keep a larger sample size. However, it can create biases when it comes to the analysis. The other thing to look at in terms of missing data is, should there actually be missing responses here? So if you have a skipped question or a skipped question logic within your survey design, as in if someone answers yes to a question, they might be skipped to 3 questions ahead, meaning that there's 3 questions that yes respondents should be missing for. So this is where in the frequency we check to see whether those yes respondents have actually been skipped past the questions that only the no respondents should have been answering. So that is something that's important to check, because particularly in self-completion surveys, people may not be paying enough attention to realise that because they answered yes for question 10, they should be skipped towards question 16, for example. The other thing to do in terms of descriptives is to look at your range of responses. So if the scale is between 1 and 7, the range of responses should be between 1 and 7. And we see for this item, our response range is between 1 and 6, which falls within the parameters of the scale that was used to measure it, so we don't have any respondent or inputting error here. Other error checks that can be done. So I talked about adding those survey IDs or respondent IDs to the top of all of my handwritten surveys. That let me do random checking of originals versus the inputted data. We can do negative question checks. So in the design, I had those questions that were negatively coded. Well, they need to be reverse coded, or they were negatively phrased questions. These can be used to make sure that respondents were paying attention, because if they're giving all positive responses, 4 and 5, to the positively framed questions, then they should be giving responses in the 1s and 2s to the negatively framed questions. Look at the missing data. Like I've already said, you need to either replace with the mean or delete the response from the data set. And finally, you need to document all of the decisions and procedures that you used. For example, if you are using option 2 in your missing data solutions, then you need to report that we received, for example, 100 responses, but 5 surveys were eliminated from the sample due to missing data, giving a final sample size of 95 respondents. This is how these kinds of decisions are reported. Okay, finally, preliminary data analysis. So we're talking about data description here. Who is included in our sample? So this gives indications of the representativeness of the sample versus the population, and gives us a sense of who it is about who we are doing the analysis on. So this includes 3 stages: data tabulation and looking at measures of central tendency and dispersion. So what we're looking at here, so we've got frequency distributions, measures of central tendency, measures of dispersion, and measures of distribution shape. So stick with me here. So frequency distribution is how far along a scale our respondents lie. Measures of central tendency is how peaky versus flat our respondents tend to sit. Are they all sitting in the middle, or are they ranged along the measurement scale? Measurements of dispersion. Do we have a lot of people at either end? Do we have are people not centered around the mean? Do we have these kind of skewness? And the distribution shape, so this idea of peakness versus flatness. So frequency of distribution, the ordered array of observed variable values and the frequency at which they occur. So I have it in doing my frequency analysis, I have it in 2 forms. I have it in numbered form, where I can look at the percentages, I can look at the counts. So this is the counts of respondents along these measurement scale options. This is the percentage of the sample that sits along these scale options. We can do it by accumulation, that make sure it adds up to 100%. Because I'm visual, I like to look at it in the histogram form. So this, because I got the normal distribution shape, I can look at the actual distribution versus what a normal distribution would look like. And as I can see from this histogram, we have slightly higher than expected people responding at just below what would be a normal mean. So the measures of central tendency. We have three ways of measuring this, and which one you would use depends on the type of data you have. So the mean is the sum of all observations divided by the number of observations. This is relatively straightforward. It's also called average. It's something that you probably should have been taught in primary school. However, we use the mean to report the central tendencies of our data when we're dealing with interval or ratio data. A median is where we take the value, basically we range our values, responses from everyone who said 1 to 2 to 3 to 4 to 5 to 6 to 7. We range it along in one great big long line, and we take the observation that falls smack bang in the middle of that range of responses. So median works best for ordinal data, but it also is used for ranking data, and often you'll hear the median referred to in cases such as house prices, where you might not have that many observations and you might have a large difference between your upper and lower end data. So in this case, the median is 4, whereas the mean was 3.62. So the most, in terms of the range of responses that we had, out of 7, the one that fell in the middle was 4. Mode, on the other hand, is the most frequently occurring value. It can be used for any type of data, but tends to be used for binary or categorical data. In this case, the mode is 3, which is below the mean and also below the median. Modes are most often actually, in terms of males and females, kind of categorical data, often actually reported more in percentages than in counts. So the measures of dispersion. So this is how far along our scale our data is distributed. So the most commonly reported measure of dispersion is the standard deviation, which is the square root of the variance. However, we do have range, which is the largest value minus the smallest. So in this case, the maximum that was reported was 6, the minimum was reported was 1, which gives us a range of 5. So even on a 7-point scale, people might have, everyone might respond 3 or 4, meaning that it's 4 minus 3, giving us a range of 1. So a very, very undispersed data set. Variance is computed by summing the square differences from the mean for all the observations and then dividing by the number of observations minus 1. I know, don't worry about it. Here it is reported right here, 1.764. However, the standard deviation is the square root of the variance, and when we look at the distribution, it tends to be how, in terms of how many respondents fall outside of one standard deviation versus 2 standard deviations, so on and so forth. And the coefficient of variation is not produced in SPSS statistics, and it's not necessarily something that we often report. It's just a slightly more sensitive measure of dispersion. So if we look at our histogram, we have our standard deviation of 1.328. So what would that suggest is that we have a slightly more distributed sample than a normal distribution would suggest. So one standard deviation would be 95% of our respondents would fall within one standard deviation, whereas we are 1.328 standard deviations where you'd have 95%. Measures of distribution shape. So this is peakiness versus whether it's skewed one way or the other. So skewness basically is whether our shape is towards the mean, or the peak is towards what a normal mean would be, or whether it's shifted towards the left or right of the mean. So here we have our skewness output. So a skew of greater than 0 means that the distribution is skewing slightly to the right of the mean, where a skew of less than 0 skewed negatively to the left of the mean. And kurtosis describes the flatness versus peakiness of the distribution. This has got some funny words here. So leptokurtic, which is the peaky, so pointy, if it's greater than 0, it would suggest that it is more pointy than expected, whereas less than 0 is platykurtic, which I called flatty, so how more like a plane or unhill-like the distribution is. So in this case, it's minus 0.674, so therefore we have a relatively flat kurtosis in terms of distribution. So in terms of this, so we're slightly to the left. As you can see here, it's a bit to the left than a normal kurtosis one. A normal skew, which would be here. We are peaking over here in terms of the dispersion in this case. And kurtosis, the normal suggests that it would be to this point, whereas we are a little bit flatter than expected with our distribution down here. So that is for a single table of our variables. The next thing we can do is a cross-tabulation in terms of descriptive statistics. So this is used to describe the relationship between two categorical variables without testing necessarily for statistical significance between those variables. It is very commonly used in analysis in marketing research projects, especially looking at describing relationships between demographic information and purchase or usage information. So the decisions you need to make with cross-tabulation of what are the categories of variables to be tested, variable selection and any recoding that you might need to do, and what does the outcome mean in terms of the interpretation. So to run a cross-tab, again, it's one of the descriptive statistics, and just to be aware that it doesn't actually matter where you put your variable. So it doesn't matter if I put gender as a column or usage as a row, that makes no difference in terms of the analysis. So to show you what this looks like in SPSS, I go back to my Delhi depot data, I go to Analyze, Descriptive Statistics, Crosstabs. So I'm going to put gender in the row and I'm looking at usage in the column. I ignore statistics at this point and I go to cells. And I can select the percentages, some of the most commonly chosen. Often we also add expected, but I'm not going to do that for this purpose. So here is my crosstab output. As you can see, I have no missing cases. I've got 100% of my data being considered. So how do we analyze this data? So I'm just going to look at within gender outputs. I can then look at within usage outputs and make different interpretations. So if I look at within gender, females, 23% are light users while 76% are heavy users. So the majority of female respondents are heavy users. Looking at the male with gender, 65% are light users while only 35% are heavy users. So what does this mean? Well, Deli Depot's highest usage customers are female. So Deli Depot should target females in terms of, for this particular question. If the question is who should Deli Depot target, the answer is Deli Depot should target females. There might be a different research question, which is how can we improve our sales? And the answer there might be we might need to target males to encourage them to use more. But that is a different question with a different interpretation. So just be very careful about how you interpret it. Please also notice that I make no conclusions about why females are higher users than men, and I make no conclusions about why men are light users. I also make no suggestions at this point. The reason I can't make any speculate as to why females and males are different in terms of usage or suggestions for their different using behavior is that further research is required. So either you have collected the data to explain why these differences occur and or collected data to look at what suggestions would be appropriate for these different genders and usage types, but until you analyze that data, you can make no further conclusion than what I have stated here. So this is the end of the lecture on how to input your data, how to run your initial checks on your data, and also do your initial data analysis in describing your sample.